America, land of the free, home of the brave, and home of restrictive immigration laws. In our fast-paced, business-focused society, we need to save as much time and money as possible, but we also want to employ the best of the best people from all over the world. To do so requires our employees from overseas to have a visa. The average work visa costs anywhere between $1,450 and $2,860 US, not including the cost of time to fill out the paperwork. That's a lot of time and money for a single application, especially if the applicant gets rejected. Our solution: find a reliable way to predict whether or not an applicant will be accepted before they apply. We took data from the United States Department of Labor between the years 2012 and 2017. This data was extensive with 154 fields and 375,000 applications. Before beginning this undertaking, we researched whether other people had solutions to this problem. We found other research that had been done with more limited scopes, only looking at one type of permanent visa, the H-1B, with a data set that only had 7 features. Whilst doing our own project, we found one other paper that had been published that used our same dataset, looking at just the L1 visa, not the entirety of the dataset. After looking at the data and the previous research, we began pre-processing it with the most reliable and usable features. Many of the features were very sparse, with only about 1% of our data having them, or anything in the field at all. We had to clean some of the data, such as the postal code feature in which license plate numbers or state names were written. The major issue we had was that some of the fields had the same tag, but they had conflicting data, or the same field tag, but different data types, like an integer instead of a string. This is most likely because of the different application types that were submitted. So, to limit these conflicts, we combined some fields and found the most accurate or well-represented data, and looked at the most important data within the documentation that came with the dataset and off the US Department of Labor website. We decided to use a neural network and a decision tree on the data to see which would work better. The neural net gave us around 70% accuracy, and the decision tree with the Gini index decision metric gave us 85% accuracy at first. The program takes 2 inputs. The first one decides whether the program should use the country of origin or not. The second input to tell the program to predict the application based on which visa was applied for. In this project, we imported pandas to help read the CSV that was provided. We also used sklearn for the decision tree, the accuracy metric, and the model selections. After the CSV was read into panda's data frame, we filled in all of the empty slots with a random float value that did not appear in the data. This number was used because it was not in the dataset that was provided and would not be split upon. Next, we take out the column that is the correct classification for the row. Then we split the data into testing and training data. We split the data with 89% in the training and 11% in the testing. We created an instance of a decision tree classifier from sklearn with the following conditions: that it used a Gini index for impurity, that it needs a minimum of 8 nodes to split, that it would stop early if the minimum impurity is less than 1 times 10 to the negative 7, and that it splits on a random best split. We then fit the training data to the decision tree and then score it based off the testing data. With these parameters, we were able to get 85% accuracy. We then decided to look at the tree that we had made. We realized that it was too expansive and believed that we were overfitting, so we adjusted the minimum split based off accuracy and favorability of larger splits and got better results. We were then able to achieve 90% accuracy. We believe that this would be good enough for employers and executives to be confident that their employee hopefuls would be allowed to enter the US workforce legally, while saving money on those who did not make our predicted cuts. Future improvements could be made if our data was completer and had less noise. We could also fill in the missing data by k-nearest neighbor approach instead, so that the data would hopefully be truer to the source, which would give us better accuracy in the end. We could also figure out what type of visa one person would most likely be able to attain, just in case a person has a better chance of getting a JL2 visa instead of an H-1B. This might help with people who could work with multiple types of visas, but might not be able to attain one of them. That way, money would not be wasted applying for multiple visas.